Vishnu, and I'll be teaching the Junior Advanced Session 3 class today. Welcome to Session 3. This session is going to be about number theory. I apologize in advance, I'm a little sick, so my voice is slightly off, so just bear with me on this one. So the topics that we'll be covering today are divisibility rules, factoring, prime numbers, prime factorization, and least common multiple. Now, for the sake of understanding, I've decided to go a little out of order on this list. I'm first going to cover divisibility rules, and then I'm going to jump to prime numbers, prime factorization, then go back to factoring, and then cover LCM. 3.1, divisibility rules. So this is practically the exact same chart as the one in your lecture notes. I'm just going to quickly go over each one. So for 2, if it ends in an even number, said number is divisible by 2. So numbers like 2, 4, 6, 8, and etc. If they end in a number divisible by 2, said number is divisible by 2. Also, something that's very important is the number 0 is even. So if said number ends in 0, that number is also divisible by 2. For 3, if the sum of the numbers is divisible by 3, the number is divisible by 3. So if you go through and add every single digit and divide it by 3 and have no remainder, the number is divisible by 3. 4. The last two numbers must be divisible by 4. So if you just take the last two numbers, the tens and the ones place of the number, and you divide it by 4 with no remainder, the number is divisible by 4. 5, this is one of the easiest ones. If it ends in 0 or 5, it's just divisible by 5. 6, so for 6 what you have to do is you have to do the 2 and the 3, and if it successfully does 2 and 3, it's divisible by 6. Now 7 is a really special number. There's no easy way to find if a number is divisible by 7, so the easiest way to do it is just do the division. If you don't get a remainder, then yes, it's divisible by 7. Number 8. Check the last 3 digits and see if it's divisible by 8. Simple. And number 9. Sum of all the numbers must be divisible by 9, therefore the number is divisible by 9. 3.3. Prime numbers. So numbers can be defined in two major ways. You can define them as prime numbers, and you can define them as composite numbers. Prime numbers are numbers whose only factors are itself and 1. An example of this would be 2. 2 can be written as 2 times 1, but nothing else. This is really important because 2 is the only even prime number. Any other even number greater than 2 can be defined as a composite, which I'll get to in a second. Now, composite numbers are numbers who have factors other than itself and 1. They're basically the exact opposite of prime numbers. So, an example of this would be 4. Now, 4 can be written as 4 times 1, but can also be written as 2 times 2. Therefore, it has factors other than itself and 1. 3.4, prime factorization. So what prime factorization is you take a number and you find all of its factors and you write the number as the multiplication of prime numbers. What I mean by this is you can take a number 28 and you can break it into 2 more numbers. In this case I'm going to do 4 and 32. Now once you get these 2 numbers, you can break this down even more. 4 becomes 2 and 2 and 32 becomes 4 and 8. 4 once again is 2 and 2. 8 is 4 and 2. And 4 is 2 and 2 again. What I've done right here is I've broken down 28 into prime numbers. 2 cannot be broken into the factors of 2 more numbers again, because the only other factors you can write them as is 1 and 2. For this reason, we have broken this number down all the way to its prime factorization. Since there's 1, 2, 3, 4, 5, 6, 7 2's, we can write 128 prime factorized as 2 to the power 7. Now, if you guys don't understand the exponents right here, I please do recommend that you guys check the exponents lecture notes or the video for this. 3.4, prime factorization. So what prime factorization is breaking down a number to its prime factors. What I mean by this is you can write any number as a multiplication equation of prime numbers. That's what I'm going to show with this number right here, 128. So 128 can be written as 4 times 32. This is the same thing as 128. 4 can be broken down into 2 times 2. Therefore, 2 times 2 times 32 is still 128. 32 likewise can be broken down into 4 and 8, so if you still multiply all of these, it's still 128. And 4 can be broken down into 2 and 2. Now since 2 is prime, you can't break it up into any more numbers because the only other number you can break this into is 2 and 1, which is basically the same thing as 2. Then 8 can be broken down into 4 and 2, and 4 can be broken into 2 and 2 again. So what we've done right here is we've taken the number and we've broken down its factors all the way till we get prime numbers. Once we get prime numbers, that is the end of our prime factorization. Now what we can do with this is 128 we can represent as the prime factorization of 1, 2, 3, 4, 5, 6, 7 2's, or 2 times itself 7 times can be written as 2 power 7. If you guys don't understand exponents, I highly recommend that you guys check the lecture notes for that and the exponents video for this lesson. 3.2, factoring. So as I explained earlier in the video, I told you guys that I'm going to go out of order. So now I'm jumping from 3.4 all the way back to 3.2. And the reason is because in order to do factoring, I think that the easiest way to do it is using prime factorization. So I have another number right here, 288, and I'm going to prime factorize it. So if you guys want to do this on your own, I encourage you to pause the video and try it out on your own, and then once you're done with it, just check your answer against mine. So this would break down into 2 and 144. Now if you guys know your perfect squares, you would know that 144 is 12 times 12, and these two break into 2, 6, and once again 2 and 6. 6 breaks down into 2 and 3, and 2 and 3. So what we have right here is we can write 288 as 1, 2, 3, 4, 5 2's and 1, 2, 3's. Now what we can do right here with this information, that does not look like a 5, okay, that looks more like a 5. So what we can do with this information is we can figure out all the factors for 288, and we can also figure out how many factors there are. So I'm going to first cover to figure out how many factors there are. Now what you're going to do right here is each one of these prime factors has an exponent. What you're going to do is you're going to add each one of them by 1. So 5 plus 1 is 6, and 2 plus 1 is 3. When you multiply these two numbers, you get the number of factors that there are. Once you get this, you can multiply these prime factors in any order that you want until you get 18 different factors that multiply to get 288. So you start off with 2 and 3, which would be the prime factors. 2 times 3 is 6, which is another factor. And then you can also do 2 times 3 times 3 times 3, which would be 18, and so on and so forth, until you get 18 numbers. Once you get that, you know that you have all the factors for 288. 3.5, LCM and GCF. So I know on the lecture notes that it has LCM and GCF as 2 different chapters, but the way I'm going to teach it in this video, I think it would be easiest to group them together into one chapter. That's why I have labeled it 3.5, LCM and GCF. So if you want to find the LCM or GCF of two numbers, you're going to draw a little box and you're going to put your two numbers inside this box. Now what you're going to do after that is you're going to find the greatest factor that you can think for these two numbers. So at the moment, the greatest one I can think about is 2. 2. So once you get 2, this becomes 39, because 78 divided by 2 is 39, since you're taking a 2 out from each one of them. And 2 gone here is 42. So what you've basically done is you found a factor, and now you've divided it from both of these numbers and put it outside. Now these two are the divided by 2 versions of these two numbers on the top. Now you're going to keep repeating this step right here until you get these two numbers to have no factors in similar. So the next one would be 3, because 39 divided by 3 is 13, and 42 divided by 3 is 14. So after this, you get the next level. Once you're at the next level, all you have to do is figure out that there is no common factors between the two, and you can easily tell that because they're two consecutive numbers. So once you reach that level, all you're going to do is put a 1 over here. Now once you get a 1 on the side, you know that your job is done. Now if you want to find the GCF right here, the GCF is just a product of all the numbers on the side right here. So 2 times 3 times 1 is 6. That is the greatest common factor between 78 and 84. Now the LCM is the GCF times the two numbers on the bottom right here, the lowest level. And once you do that, you'll get 13 times 14 to be 182 times 6, and this is equal to 1092. And that concludes the video for Session 3, Junior Advanced Algorithm Circle. I hope you understood number theory pretty well. If you have any questions, leave them in the comments below. Any suggestions, if I'm boring you out, please tell me. I will try my best to make sure that this video is very fun. If you really like the video, please give it a thumbs up. Please subscribe if you already haven't, to the Algorithm Circle channel. And thank you very much.
Don't forget to subscribe and like. If you have any questions, you can email info@algorithmcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!